Hey, what's up, people? Alright, back again. Let's finish this shit. Alright, new day. Today's the 5th. Ooh, shit. And, what are we doing here? Okay, so yesterday we continued going through second/final pass of save logic save state function to implement save logic associated with master save object list. Yep. Yep, that's pretty much it. Stopped at line 220 in save logic. Let's go ahead and restart our extensions, set our timer here. And I'm fucking exhausted, bro. I don't know, whatever. Always tired, right? It's just how it is. Tired. Forever tired. So let's go over to line 220 and see what we got going on over there. Stopped here. Review added. Next is review added code which handles ID integer primary key auto increment for proper ordered saves and loads. Okay, so yesterday we added the third column, which to the database, which is the ID column, which is going to be the it's going to be an ID, it's going to be an integer, it's going to be the primary key for each row, and it's going to auto increment. Basically, the way that this will exist, or will work rather, is whenever we do insert into the database, it is going to automatically have a first column, because when we put replace into save data and then we prefix the values clause with this this set of column names, it will since we exclude the ID name, and because it's an auto increment column, it will automatically fill that column in for the associated row. So this line will also add in a third column to each entry, which is actually the first column, and it's going to be an ID that identifies each row that we add to the database, so that whenever we subsequently load from the database during a load state, we will we use select object name value from the save data database table, and we do order by, so we order it by the ID. So that means the order that we enter it into the database is the order in which it will be retrieved from the database. So that's pretty cool, right? So we needed to have an ordered system because the sequence matters, which is why we have the dictionary in a certain order, because we iterate through it using a for loop, which is going to start at the first, it's going to go from the beginning to the end in that order. So yeah, that is important because certain objects have to be loaded in prior to others. So I think these are the only lines really that we need to review. I think there is another select. Is there another select that we used? I can't really remember. Let's see here what we got. So we have save logic like test. We don't want to look there. Okay, so this is a select exists. Yeah, so this is the only place actually, so that's fine. Now let's okay, I didn't know you could do that. If you did control page up, that is like the same thing as doing Oh, it switches from tab to tab amongst the tab groups. So that's kind of cool. I didn't know about that keybind. I just figured that out on accident here. On accident, I figured that out. Oh, it switches from tab to tab. Tab to tab. Okay, so I would say we reviewed. That's really all we changed. We really didn't change much. That was it. So this is done. DB order by auto ID auto. DB order by ID auto increment. We added encode. We reviewed that code. Yeah, that's done. Now we need to review P1 play cards 3 in save logic master save object dictionary. So let's go over there. There we go. Review edit code. Yeah, we reviewed that. Get rid of this. After next, review P1 play card. Yes, that's what we're going to do now. Okay, so let's hop over to that. Let's see what our bookmarks are looking like. Okay, that's better. Alright, so the one that we need to look at now is going to be the P1 play cards. And we wanted to verify, I think we put a question mark here as far as the classification ID because we wanted to verify that it was indeed a meld group and not a card group. So let's go ahead and see what we do in progression here. Let's search for play cards dot append and see what kind of operations we do on play cards. So we append a temp meld to it, so it is a meld group there. That was easy, right? Now we know it's a meld group. It is not just a card group. It is more than that. It is a meld group. So that has been verified. So that's done. Okay. Next, we have to finish the logic for the reconnect save data. So finish function save from save logic for saving data. Use comments from save logic master save object dictionary to write out this logic / code. All right. And that is what we were doing yesterday down here. I think that is where, yeah, we have this bookmark. So let's. Okay, cool. So yeah, we can leave the bookmark there. Alright, so let's start at the beginning. Well, this is load state. I'm tripping. Let's go back up to save state. That's really the one we want to work on. We don't want to work on load state yet. Alright, so let's review from the top here. We have the save state function, and when it gets called, we assign this database path. We use the context manager to create a connection to this database. We assign cursor. We set up the pragma settings for write-ahead logging and setting up synchronous mode. We create the table if it doesn't exist. The table called save data. We have 3 columns. The ID, which is going to be an integer type. It is also the primary key, and it is auto-incremented. We have the object name column, which is a text type, and then we have value, which is a blob type. Yeah, there we go. Then we have iteration through the keys in the master save object dictionary. We have a reference note which tells us the save load data method classification type, or we can just call this a classification ID. Same difference. And then we have, so that number 1 is simple save, 2 is card list, 3 is meld list, 4 is oddball. And we have if self master save object dictionary at key is equal to 1. Okay, so this is for simple save. So for each key, we're looking at the associated value, right? So we say master save object at key is equal to 1 if it's a simple save classification, and that is correct. Okay, so we get to double stamp of approval. Then we would grab the associated object via the key, which is the object name. So we need to add in the code for that. So how do we put this in code form? So is equal to 1. We would grab the associated object via the key. So how do we do this? How do we grab the associated object? Well, I know we have the string. We have the string, which is the object name, which is the key. Okay, I thought we had a plan for this. How do we actually do this? So we did have a plan for this, right? Because we saved it in the exact form that it would need to be in. For instance, like, this is how we refer to the object. If we were to modify it or access it, we would just remove the quotations around it, and it would just be change attribute list .c1 apply counter. And I thought, I thought there was a clever way to do this. Didn't we have some sort of clever thing worked out? I could have sworn we did. I could have sworn we had some clever shit worked out to where we were going to be able to easily access and assign these objects. Or, we were going to be able to, like, save. Well, wait a second. Well, yeah, we do have to get the value. And I don't really want to use eval, because eval is so slow. Remember, we determined that evaluate or execute is extraordinarily slow. Isn't that right? Like, I know we tested that. Let me yes, ChatGPT this. Python exec and eval very slow compared to things like if, elif, etc. Yes, you're absolutely right. Exec and eval are significantly slower than regular control structures like if, elif, function calls, and or even dictionary lookups. Exec and eval are slow because they have a dynamic compilation overhead. They parse a string into Python bytecode at runtime. This adds parsing, compiling, and sometimes name resolution cost every time they are run. They often require evaluating or modifying globals locals, which adds extra context handling overhead. Loss of bytecode optimization. All Python code is compiled and optimized ahead of time. Exec eval bypass many interpreter optimizations. Python applies additional protections and checks for dynamic code execution, which further slows it down. 30 milliseconds. Function calls 50. Dictionary dispatch 60. And then eval is 2000. It's like, yeah, it's literally like 20 times slower than an if elif. It's so slow. Exec's basically the same thing. 50 to 100 times slower. So much slower. Okay. If you're using exec or eval, consider dict a function. For dispatching logic or selecting operations dynamically. Ops add lambda. If elif for simple conditionals. Literal eval if parsing only literals, safer and faster than eval. If parsing only literals. What does that mean? I don't know about this. This is new to me. When you should use eval or exec. Basically, only when you're building a Python REPL or scripting interface, you're processing user-written expressions where dynamic code really is necessary. Even then, use with caution, consider sandboxing or filtering inputs. As literal eval is safer and usually faster alternative to eval if you're only parsing literals like strings, numbers, lists, dicts, booleans, none. Eval can execute arbitrary code which can be dangerous. From AST import literal eval. Literal eval is generally faster than eval for simple. It only allows literal structures, not function calls or imports. Literal eval. Literal eval is generally faster than eval for simple cases because it doesn't need to evaluate full code or handle arbitrary scope and bindings. It's just parsing into an AST and checking if it's safe. Reading config values from text. Parsing literals from a file. CLI or a database. Converting stringified data safely. Not for if you're trying to dynamic references like x plus y or max, then literal eval won't work. You need eval or a different design. Which is like, okay. So first I need to know, what are literals again? Literals are fixed values that are written directly in code. They're not variables or expressions, just raw values. Hello world. They're not variables or expressions. Okay. Gotcha. That makes sense. Okay. String, int, float, boolean, none, list, tuple. Okay. Literals are things you can type directly in your Python code without needing quotes, functions, or calculations. 5 is literal, hello is literal. Okay, gotcha. Okay. Accepts only string, bytes, int, float, complex, list, tuple, tuple, none. Function calls, variables, imports. So we couldn't even use that. Okay. If we are saving to a DB using SQLite 3 in Python, and we save the object name namespace as the object name column in the form of a string, i.e. p1.name is equal to p1.name, and we assign the object name as the key to a dictionary where the value is an integer which is 1 through 4 depending on the data type and how it needs to be handled to be saved, i.e. serialized or converted to from Pygame object to integer prior to serialization, etc. And we are iterating through this dict the keys, aka object names, and we want to access the actual namespace data, removing the quote around the object name to access the actual object. How could we do that? Without using eval or exec. You're trying to dynamically access object attributes from their names as strings, like P1 name to P1 name, without using eval or exec, and that's smart. Those functions are risky and slow. Safe alternative. Yeah, get adder, but then we still have to have the object name. That's what I was trying to avoid. Python provides get adder for this exact use case. For dotted names like P1 name, you can split on the dots and use get adder recursively. So you have class player, it's got name and then HP. P1 equals player, and you have metadata, looks like save map. P1 name is 1, P1 HP is 2. Okay. To get the actual value behind P1 name, do this. Import sys, resolve adder, data name string, root ns none. Resolve attribute. Data name string. Root ns none. Okay, so that's a type. Root ns, what the fuck is that? Parts equals dotted name dot split. Okay. If root ns is none, root ns equals sys module main global namespace. Sys modules main. I don't know, what does that mean? Object equals root ns, which is sys modules main. Then we say for part in parts, object equals get adder. So you're getting the attribute using the object, which is sys modules at main. Oh, so you're accessing the global namespace instead of a specific object. And then you say part. So the first part would be P1. And then the second one, the second iteration would be like the attribute name, which would be like name. So then you could say it would be for part and parts. So the first iteration, it would say object is equal to get adder of P1, or rather of the global namespace and accessing the P1 object. And then the next one, wait, but what does that do exactly? It doesn't do anything. Well, that's just how you access the object, okay? And then the next one, it would say for part and parts, the next one it would be name. So then it would say object equals get adder global namespace, and then it would just look for name. Resolve adder. P1 name, Alice. Does it really work like that though? This avoids eval and is much faster and safer. Sysmodule's main gives you access to your global namespace where P1 is defined. You split the string like P1 name into P1 and then name. You then call getAttr recursively. Oh, you're walking down. That is clever. Okay, I see. That's smart. I gotcha. Okay, so object gets reassigned. Now that's some pretty smart shit, bro. That's some pretty clever. That's clever right there. That's a little. That's good. Very nice. Okay. Yeah, that's good. We can use that because object becomes the specified object, and then you just you're walking down the tree. That's very cool. So that would actually work. That's exactly what I need. That's exactly what I need to do. That is the perfect solution. Thank you, dude. You can also set attributes. To set a value safely without exec, use this. Def set attr dotted name string type value root ns. So this is the same. Why would we even, like, we wouldn't even need this to be default to none. We would just, so it's namespace. NS stands for namespace. If root namespace is none, so root namespace equals sysmodule's main. Object equals root namespace. For part and parts, sliced only the last. So we have def set attr dotted name, which is string type, value root ns equals none, parts equals dotted name dot split. Okay, and then if root namespace is none, gotcha. Object equals root ns. Okay, and then for part in parts. But why do we do this? Why do we have this sliced list? Why do we do that? Does that make sense? Because that's literally just the last. I forgot how this syntax is. If it was just the last index, it would be parts open bracket -1 close bracket. But since we have the colon, that means it's a list. Does that mean from the beginning all the way to the end? That's the part that I'm confused about, and that's just a basic thing I forgot. For part and parts, sliceless -1 object equals getAttr object part. Okay, and then you just do setAttr object parts -1. Yeah, so you okay. Why doesn't it just say for part and parts? I'm confused about that. And then I get it sets the attr. That's cool. So we'll probably use that as well, but how does this syntax work again? Snip is a core logic for safely setting a nested attribute without using eval or exec. Let me break down clearly and explain what it is doing. For part in parts, dotted name equals P1 stats health. Oh, because it's got 3 layers to it. P1 and then stats and then health. Why would it have 3 parts to it? I'm confused. For part and parts, slice -1 means P1 and then stats. So it doesn't include the last object. It's from the first up until excluding the last object. So instead of having P1 and then stats and then health, it just has P1 and then stats. Okay. So yeah, that's a sliced list that excludes the final object, the final element. So it uses getAttr to walk through each object. First P1, then P1 stats. So now object is pointing to the object that has the final attribute. So that's strange. I don't know why they have a 3-part object. Like they just literally summon that out of nowhere. Why did they do that? That's confusing. Anyway, I don't know why they did that, but oh well. This avoids eval P1 stats health and does the same thing safely. Yeah, so we wouldn't use the 3-part. We would just use this version, which would just say for part and parts, because it would just be a 2-part. So this is actually really good. I do want to test it real quick just to make sure it does work. But that's actually a really good solution. So let's go over here and open up test reminders. And we have our test segment here. God, I'm fucking exhausted, bro. Like, why am I so tired? I really don't understand why I'm this tired. Like, I just feel so exhausted. It's crazy. Unbelievably tired. Resolve attr dotted name string root ns equals none parts equals dotted name split root ns. We don't even need root ns. That's just extra. That's wasted. Okay, so we have to resolve attribute dotted name string. We don't even need that type. What is that called? We don't even need the what is it called? Type annotation. Type annotation dotted name string value any dotted name string. It's a string path. Gotcha. So it has to be a string. Yeah, that's called type annotation. We don't need that. Parts equals dotted name split. So we do need dotted name. But we don't have to put that it has to be a string. I don't really like I don't do that. We just say dotted name. And then parts equals dotted name split, and it splits it on the dot. If root ns is none, we don't need that. So we just say, first off, object is equal to sysmodules main, and then for part in parts, we can do that first, and then for part in parts, Now we say object equals get outer object part. So it starts off with this being sysmodules main, and then it uses the part to get like P1 or whatever, and then it will return this object. That is a very clever thing. It could just be, you could just do this in 2 pieces. This can be a little bit confusing. It is very clever, but it kind of requires like a little bit of thought to understand it. But that is good. That is, let's see if it works though. So now we're gonna do cd canasta testing pi test reminders. Let's see. Main has no attribute P1. Okay, right, because I don't actually have the P1, so we would have to create the class. We just say class player def init self dot name equals name, and then we have self dot, why did it do that? I don't know. Self dot HP equals 100, and now we have P1 equals player. No. And there we go. So we have P1 equals player. Now let's see if this works. There it goes. Name 100. So it actually works. Damn. That's really good. Cool. So we're going to use this. So sys modules main. I didn't know that you could do that. That was very insightful. You know how long it would have taken me to like figure that out, like before AI existed? A long time. And Python sysmodule is a dictionary that maps module names to the actual module objects. So if you print sysmodules main, you get module main from your script pi. When you run a script directly, the top level script is assigned the special name main. So sysmodules main gives you access to that script's global namespace, all the top level variables, classes, functions, etc. To allow code like this, it needs to find the P1 object by name. You need to start from the global scope where P1 lives. That's what sysmodule main gives you. So when you do object equals sysmodules main, object equals getAttr object P1, object equals getAttr object HP, you're resolving P1.HP to P1HP without using eval. This works well for scripts, but if you're writing a module or using a REPL like Jupyter, Dunder main may not have your variables. In those cases, you might prefer passing globals or locals explicitly as root and s. Let me know if you wanted to make this more robust. And then a REPL, no. What is a REPL? REPL stands for read eval print loop. It's an interactive programming environment that reads your input, the code that you type. It evaluates it, prints the result, loops back to wait for more input. Gotcha. Each prompt is a new cycle of the REPL. Okay, cool. So we're going to use this. This is really good, very useful. Yeah, and I'll actually save this because this is very clever. I'll just go ahead and comment this out, and well, first I'm going to copy it, then we'll comment it out, and then we're going to put how do we do this? So we have title, date, reminder that. So title would be clever object adder access through globals using sys modules dunder main. Reminder that a clever way to access data structures in your script from a string representation of each data object is to use sys dot modules and then dunder main dunder if each data object is to use sys modules dunder main is to use that. Okay, and then what? To recursively access first the global namespace, i.e. to access P1 or P1 game, and then the object adder inside of that object. Very clever, very useful to avoid using exec or eval. Okay, so let's go over here. So where do we need this function at? If self master save object you can add key is equal to 1. Resolve adder. So that's how we would grab the object via the key, which is the object name. So we could create this function. Let's see, what's it called? Resolve adder. We're gonna change the name. We're gonna call it let's see, what should we call it? Let's give it a new name because I don't like that name and it fucked up the indentation. Surprise, surprise. So below function, and what does it do? It was created 6.5.25, and what? Let's see. Converts string representation of a data point, i.e. p1.name, into two parts: the object. Well, it converts to string representation because we're gonna need it to do it for dual part, and I think we also have some that are just. Do we have any that don't have two parts to them? I think they all have two parts. Yeah, they all do. Yep, they all have two parts. Okay, cool. So yeah, that makes it easy. Like, we don't have to account for a one part. So convert string representation of data point into two parts. The object into two parts. The object, which would be P1, and the attribute hand to use to use getAttr to access this object data. To access the object data. Convert string representation of a data point into two parts to use getAttr to access the object data. Yep, that's correct. And we're gonna change the name because we're not really resolve attr. I don't like that. We're just gonna do we'll say object access from string function. Object access from string func. Or would we say something what's a little more clever than that? Object access from a string func. I mean, that's fine. Object access from string func. And it takes in, instead of calling it dotted name, we would just call it string object name. So then we have the parts, which is the string object name split. So we have object equals sys modules. So we do need to import sys here. And then ports equals string object name split on the dot. Object equals sysmodules main, which is global namespace. Access global namespace for part in parts. Object equals first iter global namespace. Second iter access attr. Yeah. Okay. And then we return the object. That's perfect. Okay, so now let's go down here. And we're going to call object access from string func. And what we pass in is the key, because that's literally the object name is the key. And we can just call it object name key. So we go over here and we say if so master save object dict at object name key is equal to 1. Object is from string func. then we pass in object name key. Why is this? In this color, why is it white? I don't know. Object access from string func. I don't know. And then we would grab the associated object via the key, which is actually the object name key now. Which is object name. Say object data. So then we would do object data equals object access from string func, object name key, and then we turn it into a blob by doing pickle dumps on the object data, which will serialize. Yeah, because we use dump, and that serializes the grabbed object. Serialize the object data. And then we would save it to the database. And we actually don't have to serialize it. We can just call that function, right? Can't we do the serialize and save to function db via func call? What's that function call? Or what's that function called? Where is it? Serialize and insert function. I think that's the one. Serialize and insert function, which takes self, object name, and then data. And I will insert it. Yeah, so we just need, just copy that. Paste that in there. Inserts to db via func. Okay, because it needs to be called self, right? I see, that's why it's doing that. It's got to be self dot, and this, it doesn't actually need to take in the self. What type of function is this called? A static function? Should this be a static function or a class function? We don't actually need the self. I can't remember. I think I want to say that's static. So you say object access from string func, takes in the object name key. That will return the actual object data. So that's serialize an insert function. So we're going to take in the object name. So the object name would be the object name key. And then the object data is the actual data. I think that's right. Yeah. We get the object data through the object access from string function, taking in the object name key. The object name key is going to be the actual string form of the object itself. Then we're going to run the serialize and insert function, which is going to take the object name key and the object data. It's gonna serialize that data, and it's going to insert into save data the object name value, and it's going to take in the object name for object name, serialize data for value, and then the serialized data would be for when it updates. Yeah, so that's correct. Let's see, what else? Oh shit. Yeah, so we need to figure out how to make this into, does it need to be a static function or a class function? If we have a function inside of a class, but it's just a regular func that doesn't need self or adders of instance or class, should it be a static method or a class method? I'll say static. Clear rule of thumb, if it doesn't use self or CLS, doesn't need access to instance or class, is just a utility function that happens to be grouped with the class, use @static method. Gotcha. So we'd say @static method, and then we don't have to pass self to it. So we'll just do @static. There we go. Since doesn't use self. Okay, so now that should work. Okay, so that one's done. Now we have to do category number 2 for card list. So we would run this regardless. This object data, this object access from string function, it would get run each time. And each time it would use the new object key. And then if it was 1, yeah, it would just directly serialize. And I think we're going to end up calling this once per either way as well. So actually this would be... You'd basically just pass, and then down here, after everything, regardless, insert or replace into. Okay, so we need to insert or replace into save data. Ensures ordered. Serialize and insert function. So which... Oh, this one does insert on conflict. Must be upsert, but we figured out insert or replace into is better. So we're gonna replace that. Where the fuck is it? Right here. Wait. We verified that this upsert method is the fastest via testing. Do not change. I thought we just verified that insert or replace was faster. Like, wait, what? Okay, because it only updates. Do update set is faster. Insert or replace. Replace replaces the whole thing. Right. So yeah, insert into do update set is actually the faster option. So this is insert into save data object in value and conflict do update set value. Okay, that's it. So that should work actually. So we can remove this one. Yeah, so we would remove this. Insert replace into insert is blah 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 blah. Yeah, get rid of that one. So I have self serialize and insert function object name key object data serializes inserts into DB. Yeah, so we would run that regardless at the end of the function, I think. I feel like that's the way to do this. Yeah, so at the beginning we would get the object data through object access from string func. And why is it white? I don't understand. It's making me upset. I don't know why. Anyway, so if it was number one, we would just end up running that function because we already have object data. Then if it was number two, inserts serializes and inserts to DB 1x per iteration regardless of classification ID. Therefore, nothing needs to be done here in this case. Or as long as that applies. As long as that is still true. And then here we do elif save is equal to 2. So if it's a card list, we need to create the skeleton list. Then we iterate through the actual list by saying for card in object data, because that's the actual like object itself. Then we append each card's ID to the skeleton list. So then we would say for card in object data, card.id, we would say skeleton list dot append card ID. And then yeah, it's that simple. So we iterate through the object data, appending each card ID to the skeleton list. And then we need to serialize the skeleton list and save it, but that happens at the end, right? So in this case, we would end up just renaming this to the final object data. Or we could just call it object data. So we say object data equals skeleton list. Because now it's a skeleton form of the actual list. You're just getting the card ID of each card. By iterating through the card list, you're adding the ID in order to the skeleton list. So now the skeleton list is just a list of IDs. So then we would just do object data equals skeleton list. There you go. So now whenever this last line at the end of the function down here runs, object data is gonna be that skeleton list, right? Now what we need to do is let's see, if meld list, so we need to create the outer skeleton list. So let's just do that. Outer skeleton list equals empty list. Then iterate through the actual outer list. So we'll say for meld in object data Yeah, okay. Then we're going to create the inner skeleton list equals an empty list. And now we're iterating through each inner list. So then we're going to say for card in meld, append each card's ID to the inner skeleton list. So then we're going to say inner skeleton list. What the fuck did I just do? For card in meld. Inner skeleton list dot append card dot ID. Append each card's ID to the inner skeleton list. True. And then append inner skeleton list to outer skeleton list. So we're going to say outer skeleton list. So for each meld, we create an inner skeleton list. We iterate through the meld, adding each card's ID to the inner skeleton list. Then we would append the inner skeleton list, which has now been populated with the card IDs, to the outer skeleton list. Dot append inner skeleton list. Yeah, and that will add each meld, skeleton meld, to the outer skeleton list. And then we would serialize the outer skeleton list and save the outer skeleton list, which would be accomplished by saying object data equals outer skeleton list. And then when it gets to the end of this function, the outer skeleton list is going to contain the inner skeleton list with the card IDs, and then it will run this serialize and insert function, taking in the object name key and the object data, and which is now the skeleton form of that meld group. So it would be serialized and saved. So let's just review that. We have outer skeleton list, empty list for meld and object data. So for meld in the card group, let's just say P1 melds. So for each meld, we would create a skeleton list. Then we would iterate through the actual meld. As we do that, we add each card ID from the meld into the inner skeleton list. Then we would append the inner skeleton list to the outer. And then we would assign, after iterating through the entire card group, we would assign the outer skeleton list to the object data namespace so that it would be properly serialized and saved. And then we have this needs to be changed to object name key. There we go. Object name key is equal to 3. And then we have oddball, which is self master save object dictionary at key is equal to 4. Only pertains to game card group dictionary. And we're going to go ahead and stop here. Alright, so that's line 254 in save logic. Alright, so let's cd out to the root of the project, the root project directory, which we have. We're going to check branch. We're on the feature branch. We're going to git add to stage everything, git commit -m double quote, paste in our devlog. So now we have successfully committed our staged data. We're going to git push to push up to the cloud to the remote GitHub repository. There we go. That's done. Alright, now we can close this out. And we'll go over here to programming, projects, Canasta. Copy this one. And we don't need that database file. Why is that? So this is the backup. We're gonna delete that. Accidentally made a shortcut there. Paste in the new one. Go into text, devlog, go all the way to the end. 6525. So that is indeed the correct data in the local backup folder. So we rename it to today's date to reflect the last time we had locally backed it up. Okay, so we're done. Really good progress. We're getting so close. Basically, I just have to finish that function, save state, which we're basically done. We just have to account for the card group data dictionary, which handles the XY, the display layer. It's pretty simple. It's pretty straightforward stuff. So it's probably only going to take me like 20 minutes to do that. Then I'm going to go through and like review the entire function, which wouldn't take me very long, maybe another 15 minutes. Yeah, and then we just like need to do a couple little minor things. Then we can start working on the load state function, and that shouldn't take me but a couple hours, and then we can actually go ahead and test and debug and stuff. So like we're really right there. Like we're almost done with this shit. So fucking close. Unbelievable. Actually crazy. Can't believe it. Hopefully it actually works and it wasn't a waste of time. I'm gonna be so fucking mad if for whatever reason my like design was just flawed. I'm pretty sure it's not though. I did like a lot of thinking about it. I have been wrong in the past though, so who knows? We'll find out, right? Anyway, good progress, at least in my book. I think that was good for the session. I'm gonna go eat, do the thing, go to the gym, probably come back and do one more session after that, and yeah, that'll be it.